Hey guys, IT guy Michael here and welcome to another lecture of our course Classification in Python on the Skillshare. Thank you very much for reaching this lecture out and without further ado, let's go into the Jupyter lab. This video or this lecture is going to be dedicated to something which is called feature selection. Now, what does it mean? In previous video, I showed you how you can create new columns using polynomial features, how you can explode your dataset using the encodings, the one-hot encoder, right? So when you will analyze your datasets and preprocess your datasets, you will reach the point where your dataset or your metrics will have a lot of columns, right? The new columns will be added after the preprocessing and stuff like this. And now in this situation, it's quite handy not to use all the columns. Why? Because when you will have like millions of rows and big like data frames, having even more columns will cause the algorithm to be very slow. And sometimes the number of columns doesn't always mean the great accuracy. You will see during your data science career that having a lot of columns is causing mostly troubles and not the performance improvements. Now, to solve this issue, there is something or some approach which is called the feature selection. And what does feature selection do is that it searches through the features of your dataset and specifies those which are important for the classification or for the statistic in general, right? And now there are a lot of approaches, and out of each of these approaches are applicable for all the datasets. But I just want to talk about them so you know what to Google in the future, or maybe you will just use them. But you know, in order to use them, it's quite necessary to understand some laws of statistics and mathematics. But without further ado, let's look at the first one. So first feature selection approach is called low variance elimination method. Now what does this method do is that it searches through the features, so through the columns of the data frame, it computes the variance, and the intuition behind is that when the column has a low variance, there is less information in the data. So we are specifying a threshold under which circumstance all the columns with lower the value than the threshold will be deleted from the dataset. Right? So how do we do that? Right? So first of all, notice that I'm at the beginning reading the data frame specifying the x and y, and here as you can see I'm using the scalar, right? Because you know it's quite good to have scale data in order to compute the variance. And now I on the scaled dataset, I'm applying this variance, which is the variance threshold, right? And I'm specifying that to 0.9. And I'm saying that remove all the features which are lower than 0.9, which are lower than 0.9. But then I got things like no feature in X meets the variance threshold 0.9, right? So what does it mean is that each of the features, so if you then print the variance of the columns, you will see that each of the feature has the variance lower than 0.9. Now, and this is an issue, right? So we can bump down the threshold and then end up with just some of the data. But now, what is the right value for the threshold? Yeah, and how to set this up? Well, this is sometimes tricky and this is most of the time not working correctly. So, but if you are a great like mathematician and statistician, you are able to use this in your projects. Now, another approach is something which is called univariate feature selection, which is also referred as select k-best, and it's selecting top k features based on the univariate statistical test. Now, I'm not going into like descriptions of what is the univariate statistical test. You just need to know that the chi-squared test is this kind of test which is used for specifying the features which have different like distributions, right? So this approach is another approach for the feature selection, and as you can see, it's as simple as select k-best. Here you need to specify the test which you are going to use. In this case, I'm using chi-squared, which is part of the feature selection of scikit-learn. There are also other tests. I want you to go to the documentation of the select k-best, and then you are just applying it to fit transform. As you can see, you need to train it on something and then transform also the test set. Now, this was quite simple. You also need to specify the K, which is like, well, so we want to use feature selection, but we must specify how many of the features do we want, right? And this can be sometimes tricky to what number of features do we like and stuff like this, okay? In next video, I will show you how you can overcome these issues. Now, the last thing which I want to talk about is something which is called recursive feature elimination method. Now, and before I go to this method, let's talk about like when is this method good for? Well, let's dive right into the method, okay? So this method is used always with a classifier inside there, or with a regressor in case of the regression. So what does this method do? It consists of few steps. So it starts with all features and it applies the classifier and it computes the efficiency of the classifier on all the features, right? And then in order to apply this method, you need to have the classifier which can return some feature importances. And these feature importances are saying which of the features were most useful for the actual prediction. And then in the second run, the features with the lowest importance are eliminated and the whole process is repeated, right? So then the next run is repeated without one feature or two features based on the setup, and then the next run and next run and next run, and this algorithm stops when the improvement is too small or not at all, right? So we are running this loop until there are some improvements in the accuracy, and then we are stopping this method. Now, those of you who are listening carefully can be like, well, Michal, so we are using the test set to evaluate the performance of this classifier, to evaluate this performance of this method. No, the thing is like you are always running the recursive feature elimination method on the training data set, and then something which is called cross-validation is applied. So basically what does the recursive feature elimination do is like it takes the training set and it splits the training set, the 80% of the whole set, into, let's say, 80 to 20, which is a cross-validation part, this 20 part. It runs the first run on these 80%, and then evaluates it on this 20%. Sometimes a method which is called k-fold method is applied when not only on one split is it run, but on multiple splits. So it's splitting the dataset into various chunks of train and cross-validation set, and then the average is being computed. Now, cross-validation can be quite confusing. I don't want to go in these details. The thing is, which I want to say, is that the recursive feature elimination method is being run on the training set, right? And not evaluated on the test set. So this is a part of a training, right? After the recursive feature elimination method, you have the features which are important for the algorithm which you are using in the recursive feature elimination method. So those of you who are listening carefully can have some questions, and I will just answer them right now. So if you look here, using min-max scalar, and then I'm saying, okay, run the recursive feature elimination for the logistic regression, right? So after the run of recursive feature elimination here, you will see that you will have this true, false, false, true, false, true, false, true, false array, which is saying which of the columns should be used, labeled as true, which are like most important for the logistic regression, right? So you must, or it's a good practice to use this recursive feature elimination with the classifier, which is being applied later in the classification, right? So after running this on trade set, you still need to evaluate it on the test set, right? So first you will specify which features to run, then you will again retrain the whole classifier with logistic regression on the train set, and after that you will predict on the test set. Well, this could be quite confusing, and when I was starting I also had these troubles. The most important part is the keyword recursive feature elimination, which can help you to select subset of the features, not all, in your predictions, right? Okay. Now I also, well, for your if you are curious, this is the 0.005 final preprocessing notebook, which I covered in the previous lecture, where we were comparing the performance of the classifier used with the polynomial and standard scalar. And here is the feature selection part, where I used the recursive feature elimination for the logistic regression. Now some of you may ask, so can I use the k-nearest neighbors classifier here? And the answer is no, because you need to run the recursive feature elimination only for classifiers which have the feature importances factor inside there. And in KNN, we don't have the feature importance. So we cannot say which of the features are important for the results of KNN classifier, right? So that's the reason why the recursive feature elimination is not applicable for each of the classifiers. But it's applicable for logistic regression. So I was talking about this RFA for logistic regression. As you can see, I ran it on the whole X-train prots, and I was trying to predict the Y-train in the train sample. And then I was printing the support and ranking the same way as I put here. So I want these like true, 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 false, which of the columns. And this is just saying it's the output of ranking, which is saying order the columns based on the recursive feature elimination results, right? So you can see these first two columns are very important, while the third one is not so much, and so on and so on. You can even get the names, but you need to refer to the documentation to get the names there. It's very useful. Now, so I ran it on the whole preprocess dataset, and I got these, for each iteration I got this warning. Please beware that many times the scikit-learn is outputting some warnings. Unless it's an error, just read the warning and then just wait for the output. Many times the warning are just saying you have too small dataset and something like this, like no iteration reach limit, right? So basically this is just saying I'm using not too many rows to predict, my train set is very small and stuff like this. So I just ignored it. As you can see, there was a lot of these warnings. It took a lot, like about 20 minutes, because like internally the recursive feature elimination is running the logistic regression all over again for these cross-validation sets. So all over again, the recursive feature elimination is taking the train set, splitting it into train and cross-validation. On the train set, the logistic regression is being trained. On the cross-validation is being evaluated. The feature with the lowest importance is being like deleted. Then in the next step, the train set is again split on the cross-validation and train set. Different cross-validation is being used. Less columns are being used, then the performance on the cross-validation is being computed, and then the feature with the least importance is being deleted, and again and again and again until the classifier is being improved. So as you can see, there was a lot of iterations, and if I go down, I'm pressing the page down. So if I go down, I have here, for all these columns, I have this true-false array. So as you can see, there were a lot of important features. And then there is the ranking, so some of them are least important. And then when I run the prediction, I just had a minor improvement in the precision in prediction of the yes class, right? So like the lesson learned from this is like the feature selection can help in some cases. In this, it helped just a little, and it was even worse. It even like make some predictions worse here. The recall is even lower than without the feature selection. But sometimes the feature selection can improve the performance of the classifier significantly, right? So it's like a test and repeat. Oh, sorry, like test, evaluate, improve, repeat. Test, evaluate, improve, repeat, right? You're applying various mechanisms of data science to your machine learning like problem, and you are improving the classifier as I did here. So in this case, the feature selection was not working properly. Okay guys, this was a little longer video about the feature selection. Hope you learned some mechanisms how to apply the feature selection to select important features or columns from your dataset. I hope I will see you in the next video. Thank you.